So today is May 6th, and we are still going over graphing log functions. We're going to have two kind of sets of notes today. We're going to go over graphing log functions, and we're going to go over graphing natural log functions. So we've already been working with these. This just goes back over basic definitions. So at the top we have some kind of definitions that we have been using. We have our log function for transformations. It tells us what a, b, h, and k do. It tells us our equation of the asymptote. These are just more formal definitions. So we're going to go ahead and start some of the examples. So it does say to state all attributes. So the first thing I want to do is I want to look at my equation, and I'm going to see what transformations I have. Well, remember that the transformation function says f of x equals a times log base b of x minus h plus k. So not many numbers in front, so there's no a. Our b this time is 2. There's no h, and it looks like we do have a k. So my k in this case is positive 3, so that is a vertical shift up 3. Our asymptote was that equation x equals h. Well, in this case, our h is 0. This is the same as saying y equals log base 2 of x minus 0 plus 3. The 0 doesn't change anything. So we get asymptote at x equals 0. I'm going to go ahead and make that on my graph. So that is this line right here. X-intercept is a point. It is the point number, comma, 0. So when y is 0, x is the number. So we're going to come over here and we're going to plug 0 in for y and solve. So 0 equals log base 2 of x plus 3. I want to get the log by itself. So subtract 3 from both sides. Negative 3 equals log base 2 of x. If you need to see it with the log in front, this is log base 2 of x equals negative 3. And then I'm going to convert this to exponential form, which means my x and negative 3 switch places, so I get 2 to the negative 3 equals x. So this says x equals 1 over 8. So x-intercept is the point 1 over 8, comma 0. And if I wanted to graph this, it is kind of a small point. In decimal, that is 0.125, comma 0. So in the x's, I am 0.125, so it's going to be somewhere very up close. So there's the intercept. My domain is going to be based on the asymptote in a little bit, and range isn't going to change. Our range is going to be all real numbers or negative to positive infinity. So over in my chart, I can go ahead and put in the point 1 over 8, comma 0. And when graphing these, I find it's easier to pick a y value and look for x. So if I say y is 3, then 3 equals log base 2 of x plus 3. We'll subtract 3, 0 equals log base 2 of x. I'm going to switch everything around. 2 to the 0 equals x, and anything to the 0 power is 1. So I have the point 1, 3. And pick one more for y, just any other number. Pick 4, it's the next closest one. 4 equals log base 2 of x plus 3. Start by subtracting 3 again. 1 equals log base 2 of x. Switch it around. 2 to the 1 equals x, and 2 to the 1 is just 2. So I have the point 2, 4. So now I can go ahead and connect everything as best as possible. I guess I'm going to head off in that direction, and it gets as close as possible to the asymptote. So all that's left is my domain. Domain is going to be based on my asymptote. In this case, that's 0. And if I look at my x's, it heads to positive infinity. So we are 0 to infinity, or I could say x is greater than 0, since it's everything bigger than 0. So I've got my transformations, asymptote, intercept, domain, range. I've got a little chart and my graph. So we're going to do one more example, and you will have the other two to work on. So let's look at 3. So 3, it says we have y equals 2 times log base 4 of x. Well, I have a number in the front. Number in the front is either a stretch, shrink, or reflect. So if my a is bigger than 1, that's a stretch. So this is a vertical stretch by a factor of 2. Looks like that's the only thing that's happening. We don't have an h with our x. We don't have a k. Should have done with that. For the asymptote, once again, this is x equals 0, because I could say this is y equals 2 times log base 4 of x minus 0. For the intercept, we are some number, comma 0. So when y is 0, x is a number. So we're going to plug y in to our equation. We're going to plug 0 in for y for the equation. So 0 equals 2 times log base 4 of x. Well, one of my rules for log says if I have a number in the front, I can write it as an exponent. 0 equals log base 4 of x squared. I'm going to switch everything around. So 4 to the 0 equals x squared. Anything to the 0 power is 1. So this is 1 equals x squared. And then I'm going to take the square root of both sides to get the x completely by itself. When we take the square root, we do get a positive and negative version of our answer. Square root of 1 would be plus and minus 1. But since this is a log, we cannot take the log of negative numbers. So just keep in mind, cannot take the log of negative numbers. So I don't want to use the negative one. I'm just going to keep the plus 1. So my intercept says 1, 0. I have an asymptote at x equals 0. So that's my y-axis again. Range is going to be all real numbers, or negative to positive infinity, or you can write the words all real numbers. And then I plug in another point, so I've got 1, 0. Let's say I pick 1 to plug in next, just kind of figure out where I'm going. So this time when y is 1, I have 1 equals 2 times log base 4 of x. Well, I know this is going to turn into 1 equals log base 4 of x squared. You can rewrite 4 to the 1 equals x squared. And 4 to the 1 is just 4, so I'm going to go ahead and take the square root of both. The square root of 4 is 2, so it's plus and minus 2. But I only want to keep the positive version since we can't take the log of negative numbers. So I have the point 2, 1. And I can go ahead and graph from here. So there's a sketch of my graph, and it looks like for my domain, my asymptote is 0. That's kind of my stopping place. And it heads off to positive infinity, so I can be 0 to infinity, or I could say x is greater than 0. So for the logs, you have 2 and 4 to work on. And now we're going to go ahead and look at ln. So ln is natural log. Once again, at the top, there are some more formal definitions. One thing to know is that if we have a natural log function, ln of x, the inverse is y equals e to the x, so it's an exponential. So some basic information for our graph. The domain is 0 to infinity. The range is all real numbers. So this is for parent function. The intercept is 1, 0. Our y-intercept, we don't have one. And for the asymptote, the equation is x equals 0. And this is still kind of following the same transformation rules from before. I'm just ln. So let's see number 1. We have y equals ln of x plus 2. Well, this number in the back would be a k value, which means we have a vertical shift up 2. My asymptote would be x equals 0. So I'm going to go ahead and put in, that is the y-axis. Intercept is the point, for x-intercept, the point number, comma 0. So we're going to plug in 0 for y. 0 equals ln of x plus 2. I want the ln by itself this time, so I'm going to subtract 2. Negative 2 equals ln x. I'm going to take the e of both sides. It's my inverse. Means I get e to the negative 2. And ln of x, if I have e, the ln x, those cancel and I'm just left with the x. So inverse will cancel each other. So our intercept says e to the negative 2, comma 0. If I want a decimal to kind of figure out where I'm going, this would be 0.1353, comma 0. My range is still going to be all real numbers, or negative to positive infinity. And then I have my first point of e to the negative 2, comma 0. Let's try plugging in 2 and see what we get. So 2 equals ln of x plus 2. I'm going to solve this, which means once again I start by subtracting 2. 0 equals ln of x. We take the e of both sides. So ln and e are gone. E to the 0 equals x, and anything to the 0 power is 1. So this is 1 equals x, which means I have the point 1, 2. We had the point e to the negative 2, 0, which we said was 0.1353. 0, so that's really, really close to our asymptote. So I already have a good idea of where the direction is going. So I can go ahead and connect these. And then get really, 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 really close to the asymptote. And from here I can find domain. Domain is going to be 0 to infinity. So when it comes to graphing these, find a variable, find a number to plug in. Our asymptote is going to be x equals 0. This is just following the same rules as the last one. Okay. And I really just need my transformations. My intercept, x-intercept means y is 0, so I plug it in and solve. And then range will be all real numbers. So you have 2 and 3 for the ln problems. So you have 2 and 3 for the ln problems, and then you have 2 and 4 for the log problems. So you in total have 4 problems. Should not take too long. Make sure to write your name at the top of both papers that you are turning in, and don't forget to take a picture and submit it to Canvas when you are done for a grade. And we will see you next time.